We're going to do a problem now that helps demonstrate what happens when you have forces between two objects. Right here we've got two boxes A and B, which are connected by a lightweight cord and are resting on a smooth table. The boxes have masses of 12 kilograms and 10 kilograms. A horizontal force Fp of 40 newtons is applied to the 10 kilogram box. Find A, the acceleration of each box, and B, the tension in the cord connecting the boxes. So let's start off with A. When we do one of these and we've got multiple objects that are connected together like this, one of the things we can do is assume that if they're connected by a cord like this, that they are experiencing the same acceleration because they're moving together, which means we can treat both of these boxes as a single object. We can do this because we can consider our system to be both boxes. Okay, a system is just a way you decide how to group the objects in your problem. And to start off with, it makes sense to group them together because I've got one external force pulling both of them. And so what I can do if I group them together is, first of all, I'm just going to keep this as my free body diagram. And I'm going to say that the net force equals mass times acceleration. Therefore, the acceleration is the net force over the mass. And the net force here, 40 newtons. And the mass, since I've decided to call my entire system both boxes, is 10 plus 12, or 22 kilograms. And that's going to give me an acceleration of 1.82 meters per second squared. Easy enough. To do the second part, part B, we're really going to need to separate our two boxes into two separate systems. So I'm going to do a free body diagram of each one. So for box B, look at the forces we have. We've got a normal force, I've got the weight, and I've got what I'm going to call the tension between them. For box A, I also have a normal force, also have weight, and the tension in this case is in the opposite direction. And I also have that applied force, that force of the pull. Tension shows up in both of these free body diagrams. I can use either of them to solve for tension. My experience tells me that this one looks a little less complicated. And because of that, I think I'd like to use this one. And I will. Now, I've drawn in the forces for what's going on vertically as well as what's going on horizontally. The question is, do I need those forces, and do I need to use those in order to solve for the tension? In this case, it turns out I don't. If there were friction in this problem, which we would know because it wouldn't say something like smooth up here, then that would change things. And when we introduce friction later, we will do problems similar to this with friction involved. But for now, all we have is tension. So if I take that free body diagram and look at what's going on horizontally and write the sum of the forces, and I'm going to write a little x here because it's a horizontal force, equals the mass. Now this is mass B times the acceleration. And anytime you do this, the thing you have to do is go back over here and substitute what you see in the picture for your net force. I only have one force, it's pointing to the right, so I'm going to write tension equals MBA. And since I know the mass of box B, which is 12 kilograms, and I have the acceleration, which I calculated before, 1.82 meters per second squared, I can now put that in the calculator and come up with an answer of 21.8 newtons. Let's see if this makes sense. It took 40 newtons to accelerate both of these boxes at a rate of 1.82 meters per second squared. It probably makes sense that it's not going to require as much force to accelerate only 12 kilograms as opposed to 22 kilograms by the same amount. And indeed, it's 21.8 newtons. One way we could check this is look what we could do. If we made an equation for A, we would have something like the net force horizontal equals mass A times the acceleration. And in this case, we are moving to the right, so we would have Fp minus T equals ma times that acceleration. When I solve for tension I get the tension is equal to Fp minus mass A times acceleration. Plug some numbers in. That's 40.0 newtons minus 10 kilograms times 1 well, it doesn't look so good, but we'll live with it. 1.82 meters per second squared. If you plug it in the calculator, you get 21.8 newtons. So no matter how you choose to go about this, you're going to get that the tension is 21.8 newtons. Okay, in this case, the tension drags back on box A and makes a net force that will accelerate that slightly less massive box by the same amount. You can see that using box B to do it is slightly quicker, but you still get the same answer if you use box A. The point of this being that you really can't make a mistake when you do this. There just might be one way that's quicker than the other.